afternoon.
Good afternoon. We'd like to start the sixth open seminar today. Professor Satoko Oki, is going to present her recent work on the disaster management goal site. And after that, we would like to invite some students from UP Diliman. So let me, okay. So today we have UP Diliman and USM. Are you there?
We are here.
Yes. Yeah, good afternoon. And also some students from Chulalongkorn University. Hello, Chulalongkorn University. Okay, and I think we have Hiyoshi campus, Mita campus here, and SFC campus over there. Several sites are connected already. So why don't we start Oki Sensei's talk? Are you ready? Yes.
Yes, we are ready.
Okay, good evening, everyone. Here we are.
Good evening.
Good evening. Okay. Okay, I'm Satoko Oki, associate professor at Shonan Fujisawa campus, Keio University, and my major is seismology, which is like earthquake science. And these days I also work on disaster information and education on disaster prevention. And maybe instead of introducing myself, I would like to show my students in my lab. So there are totally 35 students in my lab, and they're all undergrad students. And like when you remember the 2011 the Tohoku earthquake, maybe you call Japan earthquake. In Japan we call Tohoku earthquake or March 11th. When the big earthquake occurred, my undergrad students were like mid-school students or high school students. And when I asked them why they chose my lab, they said they could do nothing for them at the moment. And they believe that they could have done more to help the victims in Tohoku region. So what they told me is that they want to spend the rest of their college life to prevent those kind of disaster, the next coming disaster in Japan or in the other region all over the world. So I feel really happy to work with those who have a mission in common. So I'm really enjoying my campus life at Keio University. So today I would like to show the worldwide disaster trend and also introduce some of the earthquake science. And then I'll show the workshop that I've done last week in India, in Himalaya. And also show the plan for the Indonesia workshop in the next month. Okay, so the first topic is the worldwide disaster trend. I guess some of the students from Philippines, they've already know that this shows the share. The vertical axis shows the share of disaster occurrence in 2011. Can you see the color difference? Hope all of you can see the color difference. The light gray shows indicates the one in Africa, and dark gray America, and green in Asia, and white in Europe, and yellow in Oceania. So
excuse me, Professor Oki, we do not see any slides. Can you just send it via email?
Okay. スライドなしで多分見えてるとは思うんです。So, you don't see at all?
No,
Or you
no,
can't
we do
see
not see
clearly?
anything.
Oh, you can't see the slides?
We do not see any slide.
Oh, really?
Yes.
Oh, okay.
Pa-email na lang, tapos pa-project ko na lang.
Could you just email in my account and then we will project it on our site?
Probably I can send you the slides, and also you can get the video information from the Ustreams. Probably it's better to see the Ustream if you want to see the slides. I will send you the email, send you the URL as well.
Okay, thank you.
So anybody can see the slides from here. What about Chulalongkorn University?
At USM, we can see the slide quite clear.
Okay, from USM
Only
it's
the
okay.
only the background is white, so we cannot see the white and yellow color. It's not clear.
Yeah, it's not clear for me too. So, but doesn't matter.
Okay, so I'm gonna send the EBA live lecture URL. Maybe you can go into the website if you have internet access now. But anyway, maybe Oki Sensei, you can go ahead and I can send the file to Christina. Just a moment.
Makaka-stream ka dyan?
Opo, project. May connection naman po ako.
Okay, so I'm gonna continue. Okay, so those who can see my slide, you can see what this graph shows. So from this graph, like you can see that almost half of the natural disasters occur in Asia in 2011. And if I look back, of course, 2011 we had Thai flood and also the Tohoku earthquake in Japan. But if you look back to like 1970s, the trend wouldn't change. So every year, almost half of the natural disaster occur in Japan, occur in Asia, sorry. And here I add the share of number of the people who were killed by natural disaster. So again, it is very clear that 80% of the victims are Asians caused by natural disasters. And those who are affected by natural disasters, here the affected people are the sum of the injured or like homeless, I mean like evacuated people, and also people who requiring immediate assistance during the period of emergency. So you can see more than 90% of the people who got affected by natural disaster are in Asia. And finally, the share of economic damage. So, these days no one can deny, now those countries in Asia had rapid rapid growth in economy, and this data tells exactly that point. So the occurrence of natural disaster in Asia can be a risk or threat in global scale. So with those worldwide disaster trend, it's actually part of our mission that we have to build how to manage these kind of natural disasters or the risk from natural disasters. So I would like to show another figure. Do you have any idea what this is? Sorry, those who still don't see the slides, but this one actually shows the earthquakes in the world. Those earthquakes whose magnitude is larger than 5 are plotted on the world map. So if you look at Japan, like if you focus on Japan, you can see it's a really tiny country when you look in a global scale. We occupy only less than 1% of Earth's surface. So if earthquake occurs equally on Earth's surface, the share of earthquake occurrence should be 1%. But in real, it's 10 times more. So 10% of the earthquakes in the world occur in Japan, and same in Philippines or Indonesia or those Southern America or Turkey or India. Same in those countries. So when we focus on Asia, the impact of natural disaster by disaster type can be plotted like this. So now the color indicates the disaster type, and I don't think you can see those details, but the red one indicates earthquake, and the blue one, whose share is about 40%, it indicates the number of occurrence of flood. So you can see most of the natural disasters in Asia are caused by earthquake and flood. And if you look at the number, the share of the number of killed people, then the case for earthquakes exceeds to about 80 to 90%. So you see the occurrence of earthquakes among all the natural disasters is about only like 20%, but the number of the people killed by earthquakes exceeds 80%. So which means like once a big earthquake occurs, then a lot of people die. This figure clearly shows that relation. And this is the now I added those for the economic damage. So you can see as we can see, like earthquakes, the case for the earthquakes had a lot more effect for economic damage than all the other types of natural disaster. So today, because I'm seismologist, I'm earthquake scientist. Now I focus on the science of earthquakes. So, what is the earthquakes? Do you have any idea? What really it is? So here I have 3 choices. The first is like ground motion. Earthquake is ground motion. The second one is rupture in the ground. Earthquake is a rupture, the tear, or the break of the rock in the underground. And the third choice is the giant catfish, out of control.
The Dr. Uehara is laughing at.
It's like a Japanese.
Yeah. This can be a Japanese joke. Actually, this is the image of the giant catfish. So, actually, the earthquake science started only 100 years ago. You see, like mathematics, it started like 6,000 years ago, maybe. But earthquake science started 1990, 90. And so in Edo period, that's like about 100 years ago, like Japanese people believed that the ground motion is caused by a giant catfish out of control. So after the earthquake, we draw this kind of giant catfish, and people are trying to kill him, not to have earthquakes anymore, something like that. So in Japan, we still use this catfish as a mascot of earthquakes. But anyways, the answer for the earthquake, what the earthquake is the rupture in the ground. So actually, nowadays we Japanese don't think it's giant catfish, but most of us Japanese think it's ground motion. But in real, ground motion is the result of an earthquake. It's like a tsunami. Tsunami is the result of an earthquake. So ground motion is also the result of an earthquake. And an earthquake itself is the rupture. Rupture is a kind of like a break. It's kind of movement of the rock underground. We can, if you have any chance to talk to like small kids, you can have some experiment with chalk and vice. I'm not sure if you have vice in your country, but in Japan, like all the elementary school got several those vices in our art room, and you can put the chalk in the vice, and you roll it, and then the vice pushes the chalk, and it breaks like this. So it won't go like that. It breaks in that way, in the direction of the movement, the pressure. And when the earthquake occurs right close to the surface, not in the ocean like 2011, but in land, and also it's really close to the surface, we can see exactly the same phenomena as this, and it's like that. So this is the one. This is a big snapshot of the one in Kobe earthquake, which occurred in 1995. So in January 17th. So we just had 19th anniversary of this earthquake. After the earthquake, it was early in the morning, so it was really dark in the morning. But 3 hours later, when the sun rises, we saw, like all of a sudden, we saw this kind of rupture of the ground. And here's the picture from the helicopter. And this is called active fault. So the name is Nojima fault. But it clearly shows that active fault, when the movement, the rupture along the active fault is the earthquake. And when we feel it, that's the ground motion. So actually the size of this the rupture corresponds to the magnitude. So so the size of the ground motion is not the magnitude. If you are close to this rupture, you feel big shake. But if you're farther away, even though the earthquake is big, the ground motion is small. So the magnitude itself is the size of the rupture. So when I plot, this is a part of western part of it's a small part of Japan, western part. Sorry, I didn't put the Japanese map, but you can see Osaka right here, and Kyoto probably is here,
and Tokyo is somewhere further away on the right. But actually, the picture was taken here, and you see a little bit longer version from the helicopter, but the rupture actually continued to this width. So it's about 50 kilometers length and 20 kilometers depth. So I projected on surface, but in real it's vertical. So it's about 50 kilometers length and like 20 kilometers depth. So so you can imagine, like starting from your house, what is there like 50 kilometers away? So you can imagine, how far it is. So those people, for those Japanese people, like I can show it's about like from Tokyo Disneyland to Seibu Baseball Stadium, or I can say from Tokyo to Yokohama. That's only 30 kilometers. So magnitude 7, the size of magnitude 7 is much bigger than that. So the size, the area of this square corresponds to the magnitude. So the year 2013 was actually 90th anniversary of Kanto disaster. We lost 100,000 Japanese back in 90 years ago in 1923. That was magnitude 8 earthquake right beneath Tokyo. And I can plot that on this map. So this is magnitude 7, which has not occurred yet, but I'm pretty sure this will occur sooner or later right beneath Tokyo. But this is the case for magnitude 7, but for the case of magnitude 8, which really occurred in 1923, the size is like this. So our campus is right here, and I'm in Mita campus right here right now, and it's about 130 kilometers and like 60 kilometers, like big square. That's the size of magnitude 8. And you all know that the 2011 Tohoku earthquake is magnitude 9. So magnitude 7 is like this small, like 50 kilometers. When you plot it on Japan map, it's this small. And for the case of magnitude 8, it's like this. And for the case of magnitude 9, it was like that. So you see how big it was, and that is why so it's not like the strength of ground motion get bigger and bigger when the magnitude get bigger and bigger. It's not like that. The strength of ground motion has a limit. And the thing is, when the magnitude is huge, the area which got damage expands. That's the typical case for earthquake disaster. And also the height of tsunami get higher, and also the area get wider. So this is the animation which shows the mechanism of tsunami. So as I explained, the rupture occurs at the plate boundary. So the plate boundary can also be active fault. So active fault normally has. So the case of the Kobe earthquake, active fault was over here. But for the case of oceanic earthquake, the active fault is the plate boundary. So when the earthquake occurs, so the plate is plate keeps subducting beneath our country, or maybe your country, and you see there's a rupture between the plate boundaries, this plate boundary, and then the ocean bottom pushes up the water, the ocean, and that is the tsunami. So you can see the ground motion and tsunami is the result of the rupture beneath the underground. So you see the rupture, and then it pushes up, and the water just spreads, and that's the tsunami. So this is what happened in 2011 or 2004 in Sumatra. And so now I would like to talk about the Tohoku earthquake. In Japan, as I mentioned, like we call it Tohoku earthquake or March 11th in Japan, and that was magnitude 9, like mega quake in northern part of Japan. So this is the square that I showed. It's about 50 kilometers length and 500 kilometers length and 200 kilometers width, and that area corresponds to magnitude 9. And as of last month, we still have more than 2,000 people missing, and so far more than 15,000 people were killed by tsunami. So actually, more than 90% of those victims were killed by tsunami, and the earliest point which got tsunami had 30 minutes. So because the propagation velocity differs at the point, so the earliest point had 30 minutes of time to evacuate to higher grounds. And as I told you, more than 90% of the victims were killed by tsunami. So almost all the people were alive after the earthquake in this 30 minutes. So I really regret that. Why couldn't we, help, like save those lives, because they are alive in this, like the very first 30 minutes after the quake. And so I would like to show the movie, and it was shot by the city hall. It's a northern city in Iwate Prefecture. It's called Miyako City, city of Miyako, which got about 11-meter high tsunami. And the people who is working at City Hall gave me this video, so I'm gonna switch my slide and. Everybody can see this. So this guy is shouting to the people who is walking around, because this city got like a tsunami like 3 times in this 100 years. It was not like this big, but every time big earthquake occurs, this city is really like tsunami prone area. So they built 8-meter high riverbank, and also the seawall, river wall and seawall. So it's this already is 8-meter high. You can compare from the car, compared to that big car, you can see how big it is. And so actually the disaster information at that time was like 3 meters. So people thought, oh, we have 8-meter high river wall. So the tsunami warning issue says it's 3-meter tsunami is coming. So, we don't have, no bother, we don't have to evacuate. That's what people thought. But it's about like 3-4 minutes later, it goes like that. So the tsunami is coming from the ocean. So normally the river runs from that way, but you can see the tsunami is coming from the ocean. and you see those ships going up, like pushed by tsunami, and it's just like running up. And I can. Now they are mentioning the tsunami exceeds the ocean seawall. They are shouting to the people, a boy on the bicycle. So they are saying, come to the city hall. So I muted. So it's a rather small city in Japan, but more than 100 people died in this area. And the tsunami warning was issued as like 3 meters, and then like they upgraded to 6 meters, but people still didn't evacuate because they have like 8-meter high river wall. But in real, about 11-meter high tsunami attacked the city. So, even though we had this like warning system and also the fancy this like high river wall, once it exceeds, the river wall actually masked people from tsunami, and that is why more than 100 people died. And I as a seismologist, I feel really sorry for them. But we have to we try to explain what the earthquake is or the mechanism of tsunami, but we didn't tell them the limitation of our science. Like we can't predict earthquakes, or like there's a large uncertainty for the estimated tsunami height, like that. So when we issue like 3 meter, then people think it's exactly 3 meter, not 3.5, not 2.8. It's like 3 meters. So this information is really important, and that's something we scientists also have to learn about it. So to prevent those kind of disaster, at least save people's life, not the houses, but at least people's lives. Like we have to think all these things, the limitation of science, and also the human science, that people got the information but still didn't evacuate, those kind of things. So that's what I do as my research. Okay, so I have another another movie. This is a case for the city. It's a really short movie. This is a case for Kamaishi. So people say, even the Japanese high school students, they say like, oh, I can swim, it's okay, But tsunami is not, it's not like that. So you can see like only 50-centimeter tsunami can, push away those like cars, people, like sometimes like houses, like Japanese wooden house. Even though it can survive like strong motion, it won't survive 1 meter high tsunami. So those information should also be sent to the general public. So now I have a question to you guys. Which was more convincing? So I explained what the earthquake is and the mechanism of tsunami, and then I showed the video. So it's very clear that video is a lot more convincing. Even though I said 50 centimeter, like knee-high tsunami, knee-high height tsunami can push you away. Even though I explained that with mathematics, it won't convince people. But when you look at the video, it's really convincing, right? So at the very beginning, I told you the science of earthquakes. But that is a science communication. So even though I explained with photos and the fancy animation, it won't reach to the people in the aspect of preventing disaster. So, oops. Sorry. So I would also like to show you the another movie. This is the strong motion in Kobe earthquake. So this is a convenience store, typical convenience store in Japan, which is right next to the active fault. So they had really strong motion. And actually, this is the security camera, the video of security camera. So this is the case of magnitude 7 earthquake. So as I told you, the strength of the ground motion won't change if it exceeds magnitude 7, 8, 9. It won't exceed. But the thing is, the length, it's about 10 seconds for the case of magnitude 7. But because the rupture size get bigger for the case of magnitude 8, the duration time get longer to about 1 minute. And for the case of magnitude 9, it lasted for about 3 minutes. And this is also the one in Kobe. This is the video of NHK, that's the national broadcast. And you can see a guy here who is working, the whole night, and he's ready for the morning news, but he was taking nap, and then the Kobe earthquake occurred. Actually, in this company, those who are in charge of morning news shouldn't take a nap. So I heard he got scolded with this video. But anyway, you can see, those TVs or this bookshelf, it can easily fall down and fall off from the wall if you don't secure it, if you don't attach it to the wall. And same thing, as I told you, for the case of Kobe earthquake in 1995, more than 6,000 people died in this 15 seconds. In this 15 seconds, 6,000 people died. And actually, 88% of the victims were killed by the houses or the furniture. And 10% were killed by the fire. They are still alive, but since they got their legs under the furniture, so they can't escape, and the fire came and died, and the rest died because of the coldness. It was winter, so they died because of the coldness. So we can say that we can't stop earthquakes, but it's not like earthquake kills people. It's more like, vulnerable houses, or you yourself who don't secure furniture kills yourself. So this is the experiment of a real house, and you will see what will happen to these real house. So this is a really like huge space, and they moved the real house, which was at the age of 30. So 30-year-old two houses, like 30 years old, and we put reinforcement. We strengthened a house on the left, and we did nothing to the house on the right, and we had Kobe earthquake as input. And this is totally the real things, but experiment. So experimentally proved, what was experimentally proved is that if you live in old houses without reinforcement, without giving like strengthening, then your house would be like that, on the right. But it is also proved that if you have the reinforcement, and now Japanese government economically have helped them, encourage us to have some reinforcement, then you can survive. And furniture, of course, you have to do by yourself, but so earthquake itself won't kill people, but those houses or your laziness not to secure furniture kill people. So what we can say is that even though, like, I would like to ask you, who is going to secure your furniture right after my seminar? Even so, this is my big conflict, that even though people got knowledge, the knowledge alone do not give awareness, or even though they got awareness, they won't take action. So this is the big conflict of this Bosai research. So I would like you to ask, you're very much convinced and understood the strong motion of an earthquake, but you want secure your furniture immediately after after this seminar, right? So, but this is something we have to do. This is our mission, to save people from earthquake disaster. So, people always say, like, well, maybe this weekend, and that weekend it would never come, and then earthquake occurs. So to solve this kind of problem, I have now I do this educational approach to Bosai to prevent the disaster, and I would like to introduce one example. I do a lot in Japan, but I just have done a very good example in India a week ago. So I brought 5 of my undergrad students to India, and this is where I went. So we flew to Bangkok and then to Delhi, and got a 7 hours of train to the Himalaya, and this is where their mid school was. The name of the city is Tariket. Well, not city, it's like a small village. It's Tariket, and the state name is Uttarakhand, and it's 1,500-meter elevation. And the city is like that. Actually, I felt familiar. If you visit a small village in Japan in a mountain area, it seems more or less like that. And you can easily imagine that earthquakes or the heavy rain can cause the landslide, and there are so many spots that already got landslides. But I can also see the rapid growth of India. They can right after this kind of landslide, they totally how to say that, like fix the road, and road is really like flat and like comfortable, and also at the height of like 2,000 meters high, they have electricity and water and so on. So and the education was like perfect, like any children can can go to school, and it's economically it's totally guaranteed. So what we did in this mid-school was the lecture on the first day, and the second day was the workshop. And on the first day, I and the seismologist in India had some lecture, just like what I did so far. So we have to learn the earthquake science and how to prevent the disaster, and this is what happened in Japan on that day, blah blah blah. And then we provided 30 minutes of question and answer time. But those students were like really focusing on us, and they had so many questions to ask us. So it actually lasted for about hour and a half. So we answered all the questions. So they asked me what's inside the earth and why the rapture happens, or they even asked me about the solar system, and so many things. But all the questions were about science. Even though I showed the tsunami video, but they didn't ask me how we should protect our lives, blah blah blah. Then on the next day we had a workshop that what we at the very beginning we told them what we were doing on that day, and let them imagine. Everybody had a story on that day, even those who were killed by the earthquake. Everybody had their story. We let them imagine of that, and then we show them how effective to learn how to protect your lives when you're young. We showed some of the example from Japan, and then introduced how to make the hazard map. And we went out for hazard hunting, and we asked them to have some presentation. So this is what we did on the next day. So this is one of my students. He's explaining what he was doing on that day, and like 5 of my students, and this is my friend, also participated in this trip, and she had her 1-year-old baby, and it was her very first day, to be apart from her baby, and she had to walk for about 6 hours to go back to her home, something like that. So we told them, remember each of us, even to the 20,000 victims and their families had their own stories, and and don't break it up when an earthquake occurred, right? And then we went out for hazard hunting. So there are like 6 groups, and one group went inside the school buildings, and the other group went outside the building but in the campus, and the other group went out into the town. And this girl, they're all like age of like 15, and she is taking photo of this wall, which seems pretty old, and so she thinks it's a big danger. So we told them, like, try to find out big danger and small danger. But what was good is that they found out some safe, so they tried to find out big danger, small danger, and like safety spot. And after 1 hour of hazard hunting, they came back to their classroom and tried to make the hazard map. So actually they took like hundreds of pictures, but I told them, try to pick up 15 of them. And we keep telling them that you guys are representative of this school, and you have to tell how to protect your friends' lives by themselves. So try to pick up those 15 photos, which is enough convincing, and which is which can convince, and which can also give awareness to your friends who had not taken this lecture. And this is one of the examples that they made. So this seems, for me, this seems really like Indian style compared to what like Japanese medical students make. So they have this like fancy outline, and they have this like stickers outside, and like this like nice calligraphy. Actually, they spent 30 minutes to write this outline and also the title. So I was actually worried if they can, finish up all the drawing in time, but they made it. So they also had the sticker along where they walked, and they had this. They put this sticker. Nice red sticker to big danger, and they also have like small stickers for small danger. We didn't tell them. We just gave the stationery, and you can use as much as you want, and but they think in that way. They also had like a green big sticker that is for the safety spot, something like that. And we also we took photo with the iPhone, which got the GPS information. So we also we asked some of the groups to make the digital version of hazard map. So now actually we can, you can see from the Google map, if you reach to the certain URL, then it shows the hazard that those Indian students made. And then we asked each group to have like about 15 minutes presentation. And what really like moved me is that all the groups at the very beginning, all the group said something like that. This is what she said. She said, the world is perfectly safe before I take this lecture, but now I can see danger. They're not special things. They are as simple as we see every day. So she really got awareness. So it's not like, because this scientist said blah, blah, blah. It's not like that. She convinced herself. And that's why her words can convince other students. And the most impressive word from the student is from this guy. From this guy actually. After the presentation, he said, "This guy wants to say something, so please listen." And then what he said is, once more, we have to think how precious our lives are. Don't use it as fun. If you feel like using it as fun, think of your family. That's what he said. So he got like awareness, and he tried to convince other students. So from this workshop, not for the first day science lecture, but totally with the workshop, they became an actor. They're not learner anymore. They became an actor, and they got a word by themselves and for themselves, and they convince themselves, and those kind of words can convince their friends, their families. So bonsai is not something that government can do. Like we need this kind of words to each person, or like if one person find out this word, then her friend can be easily convinced, something like that. So it's almost end of my presentation, but once again I would like to make it clear that earthquakes, typhoon, heavy rain, volcanic eruption, those are not natural disaster. Those are natural phenomena. It's not disaster at all. Well, disaster happens when it is linked to human society. So if there are nobody on Earth, then however big earthquakes will not kill anybody. So it's just natural phenomena. It's not natural disaster. So before the March 11th, before the 2011 earthquake, we think science, the progress of science is the only way to prevent our lives, but it's not like that. Each person or the society itself can be wiser to prevent earthquakes, or can be more resilient to prevent earthquakes, to mitigate the earthquake disaster, those natural disasters. And here I just had I had communication yesterday with the my partner in Indonesia, that we are going to have field work in March 17th to 21st. So it's about 3 days. It's something like we did in India. But the thing is, Indonesia now, especially after the 2004 or even before, they have this educational approach for natural disaster. Not at all in India, but some in they already have in Indonesia. But we try to do the same thing in Indonesia and see the difference, or see if it still works to those teenagers. So the plan is like this. So we have on the first day we walk around the neighborhood and to see the hazard, and then next day we'll have the lecture mainly about science, and on the next day we have the workshop to make the hazard map, and this time again with the digital version and analog version. So I'm looking forward to see you, some of you, in Indonesia to work out for this field work in Indonesia. Okay, that's it. That's all for my presentation. Thank you. Thank you.
Maybe we can invite some questions.
Yeah.
Any questions from University of Philippines?
Yes, I have a question. I wonder how you predict in Japan the height of tsunamis. How do you predict the height of tsunamis?
How we estimate? Is that what you mean?
Yes, how you estimate.
Oh, okay. Okay, so so in Japan, the size of the magnitude can be decided in 1 minute. So when the earthquake happens, then in a minute we can decide the size of the magnitude, and also the latitude, longitude, and the depth. So once you got the depth and the magnitude, then we can simulate the height of tsunami. But the simulation actually costs time. So we already have the table. If the depth is this and the size is this, then this height, blah blah blah, something like that. So, but in Japan, legally, the tsunami issue is in 3 minutes. But what happened on that day, this time, is that the magnitude, the kind of it's like special magnitude. We use a special magnitude, because normally it takes a lot more time, to decide it in 1 minute. We use like a special magnitude, but the thing is the special magnitude saturate over magnitude 8. So what happened on that day is that the government thought it's magnitude 8 and not bigger than that. So they calculated tsunami with the size of magnitude 8, and that's why they issued 3 meters. And this, of course, after that, we had some improvement, and that would no more happen. Yeah.
Thank you.
Any other questions from UP? Nope. What about Chulalongkorn University? Yes?
Yes, we can hear you. Go ahead. I mean, you have questions?
Somehow we can't hear you, Chula.
Are you speaking Chulalongkorn?
Oh, so
Microphone is something. A lot of echo.
yeah.
Okay, we're going to skip it Chulalongkorn. And we have a USM.
Yes, USM. Do you have any questions or comments?
Good evening, USM.
Hi, good evening. It's not really a question, but well, very nice presentations. I think the video really tells the story. Now, I have one thing in my mind when I look through the videos and your presentations. I mean, Japan is well known for this. Well, in terms of awareness, I think Japan is probably one of the more advanced nations in terms of the people are aware of this kind of disaster and so on. But it was really surprising to see the video that people are still walking around, as if there's nothing dangerous. So if that situation happened in Japan in terms of awareness, what do you expect to the other countries, especially in Malaysia, where we don't have that kind of big disaster, so people are not really, in a sense, in tune of this kind of dangerous thing, So it will be very interesting to see how this kind of educations really make people aware of it. This is real, like showing the video and things like that. So this is only my opinion on this.
Yeah. Actually, that's actually a big issue also in Japan. So let me compare the case for 2004 Indonesia and 2011 Japan earthquake. Of course, we learned a lot from the 2004 Sumatra earthquake, but the magnitude is almost the same. It's a little bigger in Sumatra, but it's almost the same, and the depth is almost the same, and the maximum tsunami height is almost the same. And for the case of Indonesia, there are like 200,000 people died because of the tsunami. And with the tsunami information and the seawall, the number of the victims in Japan was 20,000 people. So right after the March 11th, like whenever I go to international workshop or like conference, like people say like so Japan did good job, it's 1/10, something like that. But my question is just like you, we can decrease the number of the victims, with this tsunami information and the river wall from 200,000 to 20,000. But what else can we do, to decrease the number of 20,000 to 0? That was my big question. And then I found out that most of the earthquakes, except for this 2011 earthquake, the share of the generation who died by the earthquake is always like, small kids first, and then like aged people. But this time, like almost all the school kids were survived, and that is because we had this education. And what we found out is that at the age of 40s, 80s, that share is also like really small, and they are the parents who had their children to the school. So it's like, those areas in the Tohoku, they had this tsunami education back in like 1990s. So those students learn a lot more than parents do, and they became actors. So they had this promise to their parents. So don't come to school to pick me up. Let's meet at the higher grounds. It's their homework to make, firm, promise with their parents. So that's why all the school kids were survived, and also their parents survived. So after World War II, we made too much effort to construct this higher wall, but now we try to think of like more on like software, more in like education, and that's what we try to do after the March 11th.
Yeah.
Thank you very much. Any other questions from any other sites, including Mita campus, of course? Professor Jun or Uehara-san?
Well, actually, the Oki-sensei, you mentioned about the old house and the new house, right?
Yeah.
Okay. Then it's interesting to see. I was in the site of Kobe, right 1 week later after the earthquake, and I saw all the streets, and then a lot of houses, of course. It's a kind of congested area, and then so one was completely crushed, one was bent, and the one was okay, right? And then it's a kind of diversity of the damages on the houses, right? Okay, so it's not only the old or new. Some old house, sometimes they're very strong, right? And some new. So it's not only the old or new, right? And there is a kind of a way of construction, and also the regulation at the time, maybe. So what is the various way of houses? You visited India, Indonesia, and Malaysia, Thailand. The way of construction, and from the regulation point of view, and so did you study the kind of varieties of kind of construction regulation type of a thing against natural disasters?
So in Japan, those houses before World War II is really, really strong. Like some of the buildings in like universities, like big name universities, like it's really old, but it's really strong.
Okay.
But after World War II, like we try to make it like rapid, and so then the government decided to have this building code. So don't make it too cheap, but don't make it too expensive. So they had this building code, and they changed like every 5 years or so. And what we learned, what we found out in Kobe earthquake is that the building code of 1981 is very critical. So those houses after World War II, but before 1981, it totally collapsed.
Okay.
Yeah. So it's something like that for the case of Japan, and of course Japan had one of the most strict building code, countries. So.
Oh, really?
Yeah.
Yeah, that's one part of my questions. And how about yours? I mean, you have a construction code, building code against a natural disaster. So it's really what I saw in the Kobe was a kind of a difference among those ages. That's old and new. That's right. But it's really dependent after 81, maybe. I mean, and before 81, totally different. Damages, right? Okay, so if that is the case, then probably if you can learn in your country about your regulations or the building code about the construction, that's going to be a kind of very nice action after this lecture, because it's time to time it's different, and then depend on that code. Then the kind of survival of that building, safetiness of a building, it's really depend on that code, because all the building companies doing by the business, right? So if they can be cheaper than the competitive companies, then probably the people might buy the cheaper house, but it's sometimes dangerous, right?
It is dangerous.
Okay, all right. So buy expensive houses, right? That's the key.
Yeah, so actually a lot of countries, especially in Asia, they have building codes, but the thing is, like, almost all Japanese, construction companies, they accept the law, they accept the code. So some countries in Asia, like, they have nice building code, but they don't follow it. So that's why, especially those public, like, say, like schools, like in Japan, schools, they have to build 1.5 times stronger than normal houses in Japan. That's the rule. But you see some other countries in Asia, like, they can, if it's public, then they can, steal some money. So they build, sometimes like a half strong, house, like school buildings than the normal houses. So, the important thing is, like, if your country have the building code and also the system that people follow it. So that's, yeah.
Yeah, but also I will tell you all that in a country like Japan, as we have discussed, there is a kind of strict regulation about the building houses, to make sure that the houses are safe against earthquake, right? Okay, but there always kind of there is a business space of economy. Therefore, there is always somebody who can cheat with government officials who's doing the audit of the safetyness, and then giving the money, and then kind of building the wrong buildings. And that was kind of a big news several years ago, right, in Japan. And so it's always happening. But anyway, so my suggestion to you is, check out with your code about the buildings against a natural disaster and earthquake, and compare with it with other countries like Japan, Japanese one. I hope there is an English version of the Japanese regulation, right?
Those professors in Japan, like, they went abroad. They went to New Zealand after World War II. Like, New Zealand was really, like they were
it's
the top
it's a
level
dynamic
Yeah,
country,
so
right?
we learned from New Zealand.
Mhm.
Yeah, because New Zealand is, they have this building code of, well, they didn't have building code, but they have this building technique from England, which has no earthquakes. But New Zealand is an earthquake-prone country, so they started to learn, how to, build houses, not like British, but seems like British style. So they, learned a lot. Yeah.
Oh, really?
Yeah, and
Okay.
then they have really fancy, like nice, building code. And then, Japanese, like, architects, like, they start to learn abroad in New Zealand and learn. Yeah.